Okay, so welcome to this one again. We're going to be working with the solubility of common ion. So again, we're not dissolving this in water, but we are dissolving it in a solution that contains one of the ions. So here's this one. We're going to be calculating the molar solubility of silver chromate, which has a KSP value of 9 times 10 to the negative 2. And we're going to be putting it into a silver nitrate solution. Okay, so let's go ahead and first write our equation that we need. So this is what we are dissolving in solution. So we have Ag2CrO4. Again, so now we're going to have 2 Ag, and silver is 1, right? I forgot what silver is. Yeah. And then our chromate must be a 2, because we have 1 of those and 2 of those. Okay, so there is my formula. Now let's go ahead and get our table set up. So because we have our reaction. So again, initially this is a solid we are putting into the silver nitrate solution. And when we look at it, we know that the molarity of the silver nitrate is 1 times 0 times 10 squared. Now again, do be careful. This silver is a 1 to the 1 of the whole thing. So I can use this. If this had been silver 2, then I would have needed to double this. So remember, that rule still applies. I've got 1.0 times 10 to the negative 2. Again, I'm putting it into a silver nitrate solution, which contains no chromate. So again, we're taking away, we're changing, we're losing some of the silver here and the chromate. We are adding it to this one. This one is a 2x, and we're adding it here. Okay, so again, we don't really worry about the solid piece of it, but this is going to give me 1.0 times 10 to the negative 2 plus 2x, and then this gives me just x. So our next step again then is to write our KSP equation for this, which would be your silver squared times your chromate. Okay, and again, it tells us that the KSP value here is 9 times 10 to the negative 12. Okay, and so our equation would be 1.0 times 10 to the negative 2, and that is going to be, plus 2x, jumping ahead of myself, squared, and then my chromate is x. Okay, so again, we're going to look at this KSP value, and so we are going to apply the 5% rule, and that means that we can eliminate this x, because once I take plus 2x, again, it's not going to make that big of a difference in my answer. It's going to be close enough for us to determine what happens. So again, we are going to rewrite our equation without that. Now that is still squared times the x. Okay, now again, the rest of it just becomes the math. So you want to go in and again, do like what we did before. I'm going to go ahead and move this over. It's just going to be easier. If you wanted to square it first, you could do that. And that one might be easier to go ahead and just square it, just because you've got it. It's just 1 squared. Okay, and that one you can probably do in your head, because that's a negative 4, which is going to give me a negative 8. And 9 divided by 1 is just 9. And there is my x value. Okay, now go back and make sure, and I didn't mention this last one, but make sure that this X is what I'm wanting. I want the molar solubility of my silver chromate, okay? And so make sure that that is what I actually have on my problem as my final answer. So I'm going to just go ahead. I would go ahead, and I did not do it on the last problem, but just be sure you answer the problem, because whether you do it in notation or in words, that what we are looking for is the solubility. So don't just leave it as an X. Go ahead and answer that full question on there. Now, I do want to show you real quick on there how to check the 5%, okay? And what we're going to do is we're going to calculate the change, okay? So this change that happens here, and see if it really is less than 5%. So to check that, we're just going to take 2 times, so this is going to be a check on the 5%. So we're going to take 2 times our change. Okay, so that was where all of the silver chromate dissolved. And then what we're going to do is we're going to take that, and we want to divide that by our molarity that we start off with. In other words, that this change is less than 5% of this overall change that took place. Does that make sense? So as long as this is less than 5% of the overall change, you're good. Okay, and again, you're just going to change it to percent, and that's going to give me, let's see, 0.0018%. Okay, which definitely is less than the 5%. Okay, so it's not going to hurt you. So you should kind of always go back in and double check that to see if, in fact, that your change divided by your original amount. So there, check, and you might want to note this down. It's the change divided by the original amount. Okay. So I think I was pointing here, but the change divided by the original, change divided by the original, or change over initial. Okay, so these two. Okay, sorry, you can see that. Okay, you know, I'll clarify just a little bit on that with the AP, those of you who are taking that, to see if you have to show that you checked it, or if it's okay to just use the 5% rule without proving that it was acceptable to use that rule. Okay, so again, if the math looks too nasty, there's probably a shortcut, something that you can eliminate. Okay, or as we talked about using, the other thing you could do while I'm mentioning this, you could have not worried about the 5% rule at all and done like what we talked about earlier in class and put this in your calculator into your y equals and your y equals. So you really could have just done a y equals and put that whole piece in just like that. Okay, so I would have just put all of that in, I'll highlight that, into your calculator as a y equal. And again, I would have just put it in exactly like that, y equals. And then my y2, I would have put this in. And then again, we would have hit the intersect button and just let it tell us this answer. And it really should not have been that big of a difference in there. I'll actually do that for you real quick and show you. Okay, so just so you see what I'm talking about, I did just put that right in your calculator. And then I'm going to hit the, second calc. And I'm going to do intersect, which is your number 5. I don't worry about at all. Looks like my stat plot is open on this one, so I don't really care about the graph, but let it do its thing. Okay, and then again it says first curve. second curve. I don't care about those. It wants you to guess. I don't want you to do that. And then it tells you there's your intersection. And so it gives me that my actual intersection, my x value, which is what I'm wanting, I don't care about my y value, is 8.9 times 8.3 to the negative 8. And again, if you are using significant digits here, okay, you're going to get this exact answer. Okay? So, see, it did not matter by taking that x out. Okay? So, either way is acceptable. If you feel more comfortable using your calculator, again, on your FRQs, you'll have your calculator in class. For regular college chem, you're going to have your calculator. So you use what method works best for you.